Hi, welcome to the dynamics tutorials. So in this problem we have a cylinder which has a 10 Newton force acting on it. The cylinder itself is 10 kilograms. The cylinder has a rope wrapped around an inside diameter, and the inside diameter is 0.1, and then this larger outer diameter is 0.2 meters. We have a coefficient of friction of 0.125 here at A, and then we have a radius of gyration around the center of gravity for this system of 0.130 meters. We can calculate the moment of inertia about the center of gravity just by taking the mass and multiplying by the square of the radius of gyration. That gets us the 0.169. And then looking at this one, let's guess that it's rolling without slipping, and then we'll go through and verify it. If it is rolling without slipping, our easiest equation to use is sum of moments about the instantaneous center, where it touches here at A, is equal to the moment of inertia about the instantaneous center times alpha, the angular acceleration. So let's go ahead and get the moment of inertia about the instantaneous center. And again, the instantaneous center is A. So it's going to be our IG plus our mass times the square of our distance. So it's going to be that IG that we just calculated plus the 10 kilograms times that outer radius squared, because that's the distance from the center of gravity down to A. So it gets us the 0.569 kilogram meter squared. And then plugging it into our sum of the moments equation here, we have our 10 newtons times the 0.3 meters, one radius to get to the center of gravity, and then one of those shorter radiuses to get up to the 10 newtons. That's going to be a negative moment that's generated. And there is no other moment about that point. Friction and the normal force both go through point A. The weight has a line of action that goes through point A. So this is just equal to our moment of inertia times alpha. We can solve for alpha then and get negative 5.27 radians per second. Since we're assuming it's rolling without slipping, the acceleration at the center of gravity is going to be alpha times r. Our alpha is negative, and our acceleration of the center of gravity is going to be on the positive x. So let's correct that by putting a negative sign in front here, and that gives us an AG of 1.05 meters per second squared. Now we need to go back and double check and see if that's possible. So we can do a sum of forces in the x direction is equal to the mass times the acceleration of the center of gravity in the x. That gives us minus FA plus our, forgot a decimal, plus our 10 newtons going in the positive x, and that's equal to our mass of 10 kilograms times our acceleration that we just calculated, which is in x, the 1.05 meters per second squared. We can calculate FA, and we get negative 0.545. The negative just means that friction's going in the opposite direction. So when we're pulling on this, it's creating a moment about the center of gravity, and that moment is being resisted by the frictional force, and that moment is actually greater than the drag that you create just by dragging it forward. So that's why our friction has this opposite direction, but that's perfectly okay as long as the magnitude is okay. Then we can do our sum of forces in the y direction. We'll have our weight, so 10 times 9.81 plus our normal force is equal to 0. We can calculate our normal force is 98.1. And then we just need to check and see what our maximum frictional force is. So that's going to be our coefficient of static friction times our 98.1, and that gives us a 12.3. So as long as we don't exceed positive 12.3 or negative 12.3 on either side, we're okay. We're in that rolling without slipping regime, and sure enough, we're within those limits. So it was rolling without slipping, and so now these are our two final answers. Thanks for watching.